Welcome to the Insomnia Project. Sit back, relax, and listen as we have a conversation about the mundane. One thing that we can promise is that our conversation will be relaxing so that you can feel free to drift off or just listen and relax. Thank you for joining us. We hope you will listen and sleep. Follow us at Listen and Sleep. I'm your host, Marco Timpano, and I'm very excited to welcome back Becka Barker for a part 2, or actually our first part 2 episode. Becka, welcome.
Hi, thanks for having me, Marco.
Now, Becka, we also, prior to recording, were talking about our experience with 80s alternative bands and concerts we went to, and I have a little clip that we might play as a extra. So I invite our listeners to look out for that. It won't be as relaxing, but maybe they'll get a laugh or two.
It's for when you want to wake up.
Right. There you go. So we were talking about sea slugs, and we were really getting into the sort of meat of sea slugs, not the actual meat of sea slugs, but we were getting into the nitty gritty, and we got to the end of our episode, so I said we'd have a part 2. Let's talk about sea slugs.
Well, I'm happy to talk more about the Dendrontus frondosus.
Which is the sea slug that you did your thesis on, correct?
That's right, which I did over 20 years ago now. So who knows what is known in the world about these little guys.
Fair enough.
Well, I shouldn't actually even just say guys, because as I mentioned before, they're actually hermaphroditic.
Right.
Right. And this is part of the charm of them, and actually so many animals. They're simultaneously hermaphroditic, which means they have both male and female reproductive parts active at the same time.
Right.
And when we left off last time, I was talking about their life cycle. So they only live for 1 year. They have an annual life cycle. And when we left off, we had I talked about the beginnings of their lives.
Right.
And that wasn't really part of my study. And so tonight we're going to actually start with the stuff that I studied.
Exactly. And if you want to listen to what we were talking about before, episode 25, you will hear everything you need to know about sea slugs up until this point right here. In particular, the Dendrontus.
Yeah.
I'm going to say it
you
wrong.
Got it.
Frondosus. So
you got it. There you go. Just like you just said it like you've been saying it for years. Yeah. So when these little sea slugs hit their juvenile phase, it's kind of like their teenage years or their teenage times.
Would this be like 3 months into, because they only live a year?
Yeah, that's right. Yeah, I'd say 3 or 4 months in. Like the first third of their lives is over. Right. And so now they look like the sea slug that they look like as an adult. They're just smaller. And so at the end of the summer and in the early fall, they start to settle on the rocks and on the seaweed in the intertidal zone. So the part of the beach where sometimes at high tide it's covered in water, but at low tide it's not.
And this is the Bay of Fundy we're talking about.
Yes, the ones that I studied live specifically on the New Brunswick side of the Bay of Fundy.
There you go.
And so in October and November, when they were sort of late adolescent phase, I guess, the
rebellious phase.
That's right. I collected samples of them. And then after a couple more months, I went back out in February. Oh. Yeah, it was kind of cold. And I picked more samples of them. So I picked them when they were, and when I say pick them, I make it sound like fruit, I guess, but it did feel like when you pick them off the rocks, it does feel like you're sort of harvesting fruit, I suppose. But so I gathered some that were October, November, sort of early adulthood, and then February, sort of much later on when they were fully mature.
I see.
So because I wanted to have some sense of the development that they underwent in that time.
And would you put them in a pail to bring them back to the lab?
Yeah, we would fill pails with seawater.
Okay.
And then we'd put the sea slugs in the seawater. And keep them alive and bring them back to the lab at Mount Allison, where I did my degree, and kept them alive in aquaria for until the time that I needed to, unfortunately, kill them and then study them.
Fair enough.
So So a whole bunch of little sea slugs gave their lives for me to get my degree, I suppose.
Wow.
I learned a lot.
That's great. And now our listeners will benefit from that.
I hope so.
Okay.
So the part that I studied in the sea slug was their ovotestes.
Oh.
And that's an organ that's found in a lot of simultaneous hermaphrodites. As the name suggests, ovo and testes, it is the organ that produces both egg and sperm for the animal. So, I mean, let that sink in for a second. There's one organ in these animals that produces both the male and female parts for reproduction.
Right.
So that in itself is fairly interesting, I think.
Sure.
And so my task in my thesis was to chart that development. So my questions that guided me were like, how does this organ develop? It was already known that they don't auto-fertilize, which means they're not able to fertilize themselves.
Sure.
There are sort of evolutionary mechanisms that prevent that from happening.
Okay.
Because, if they could do that, then they would just sort of be, genetically that would lead to weaker offspring.
Right.
Right? It's too much the same.
Of course.
Which, it's for the same reasons why we don't interbreed, or interbreed's not the right word, but we don't, marry our siblings.
Unless you're in the royal family.
So, and these were not royal sea slugs.
Fair.
So, so we know they don't auto-fertilize, but we did know that the organ developed in such a way that it would produce eggs and sperm at the same time. So that's kind of fascinating.
Sure.
So I had to figure out, how does it do that? And so what I did was I created microscope slides out of thin sections of the some of the animals from the October batch, some from the November batch, and then finally from the February batch. So I could get a sense through their adult life of what did this organ look like at different points in time.
Sure.
And what I found was that the organ started off just as like a circular lobe, like a balloon, almost, and it was hard to see any particular sperm cells or egg cells at that point. Now, how could I tell if a cell was a sperm cell or an egg cell?
Well, I was actually just thinking that. I know it sounds predictable, but I was like, how would you be able to tell, especially with this particular animal, right?
Well, the egg cells typically, especially when you use the staining, the stain that I was using, would be, first of all, they'd be colored very differently from sperm cells. But they'd also be, the size is just completely different, right? Egg cells are energetically, we say they're energetically expensive, meaning it takes a lot of resources in the animal's body to produce them, because they have to contain pretty much everything that the developing fetus needs, right? Except for half of the chromosomes, which is what the sperm provides.
Sure.
Right. So they tend to be very large cells. Sperm cells, by contrast, are very tiny. And of course, as we know, sperm have just the little nucleus. They're part of the cell. They're part of the DNA that they're contributing to the animal being created, and a flagellum, which is the tail.
Right.
And
so even the sea slug.
Yep.
Same.
Yep.
Okay.
Yep. Yeah. Yeah, and that's kind of fascinating. Like, a lot of species, almost, I don't know if it's all species, but almost every species I can recall studying, that's the way it is. Egg cells are these big, bulky, energetically expensive things. Sperm are energetically inexpensive. They're very easy to produce in mass quantities. It doesn't tax the animal energetically.
Right.
Takes nothing to make them. And so, which is why they can be made in such abundance, I suppose. So what I found was, at first, I couldn't see any cells that were really distinguishable as egg or sperm.
Okay.
This would have been in the first batch in October.
And were you expecting to see that?
Well, the reading I had done had indicated that most of the time in the sea slugs, there was what is called a germinal layer of cells, cells. And So the sac, so if you can imagine a sort of balloon being the organ, the ovotestes, as in that age of the animal, the October animals. So let's put an age to them. They would have been, let's say they were like, I don't know, 17.
So they're adolescent.
Adolescent,
okay.
late adolescence,
Okay.
yeah. Just post-puberty, I guess.
Okay.
I mean, it's really not equivalent, so I probably shouldn't be using those terms.
Fair, but just for sake of knowing the sort of year span of the animal where they're at, sure.
So imagine a balloon, but that balloon is lined on the inside with all of these tiny cells that look the same, that are just little round blobs, and I remember them as being purple because I used Milligan's trichrome stain, which colors that material a bright purple color.
Is that the preferred stain to use when working with sea slugs?
Well, the stain you choose has a lot to do with what it is you're looking for and what kind of biological material you want to investigate.
Wow.
And so, so two popular stains, which I used. One was a sort of, I can't remember the name of it actually, but it was a pink and purple stain.
Okay.
And but the one that was my favorite is Milligan's trichrome. That's probably why I remember the name of it. And trichrome, as the name suggests, has 3 colors. It's a very colorful stain. And so it stains things purple and turquoise and pink.
Oh, that's cool colors to be staining things.
Totally, right? And so and there was a third one that I tried actually just to try it, but I don't remember it working out very well. So for example, if something that you really want to look for in your slides is, I don't know, like a collagen material, or if you're looking for a particular kind of cell that has a certain kind of material in it, maybe something that's got a lot of protein in it or something. Different stains will sort of highlight or sort of make certain biological materials pop. And that's the cool thing about stains, right? So that was probably my favorite part of the whole project, as you can probably tell. Well, it's one of my favorite things.
As an artist, I would. It stands to reason that would be one of your favorite parts.
Yeah.
Have you ever used that stain in your artwork?
Well, I'll tell you what I did do.
Okay.
When I was completing my thesis and when I was staining all my slides, it's something I probably should not have done, but I did.
The rebellious.
Was I took some of the stain, the different colors, with a little pipette or a little stir stick, and I would sort of, on the back of my lab coat, because we all had lab coats, I actually sort of painted a little sea slug.
Oh.
But some of the staining materials is not really good for you.
Okay.
So it's probably not something I should have done, but it looked really cool. I had this sort of pink and orange profile of a sea slug on my back, on my lab coat.
That's awesome.
So, and I think that's because I had spent so many hours in the lab.
Sure.
With various slightly hazardous materials. And there was a vent, but maybe I could have used it more.
Sure.
Anyway.
Back to the slugs.
Yes, I don't want to get my thesis advisor in trouble or anything.
Well, they wouldn't have known that you were doing
It was
these
the 90s.
rebellious things, sure.
Well, he did come in at one point over the Christmas break, and he was like, you really need to turn the fan on in here. Because after a while, you just can't smell anything. You're just like, la, la, la.
Having fun.
Yep. Carefree in the lab over Christmas holidays, as you do. So the Milligan's trichrome was my favorite stain, and I remember it staining the germinal layer of cells, which is that sort of the only kind of cell that's in the ovotestes in the late adolescent phase of the animal, dyed it a bright purple. And so these germinal cells, germinal cells is a general term for any layer of cells that can become something else, that can become more specialized.
I see.
Right. So they're sort of like, like the basic cell, I guess.
Right.
And as the animal grows, the germinal cells sort of separate into 2 different layers.
So would it be like a stem cell we're talking here?
This is where I'm very rusty.
But
I think those are slightly different concepts. Okay. But that is something that we can all look up after this podcast.
And I don't mean to sort of paint you in a corner with that.
No, that's fine. I'm comfortable with not knowing things now that I'm over 40.
What's funny is I'm coming to know so much by just doing these podcasts. So
I could probably look it up on my phone while we're talking.
Let's keep going.
But it's not a completely dissimilar concept. Okay. I'll say that. It is sort of like a basic cell that can turn into something else.
Perfect.
It may wind up being the same thing. But I just remember we were calling them germinal, and for some reason I remember germinal epithelium. And I guess that makes sense because the lining of the organ would be a sort of epithelium.
I see.
Yeah.
I have no idea what an epithelium is.
Well, epithelium is your skin, basically. So it's any layer of cells that is the sort of covering layer.
Oh, so epidermis is what we call our skin.
Oh, epidermis, yeah, right. So it's, so that's the same, it's the same concept.
Okay.
Yeah.
But this is the sea slug's skin.
The inside skin of their ovotestes.
My goodness. Okay. So
there
we go.
specific.
No, we've got to be specific. This is part 2,
That's
We're not specific on this episode.
Then what are we doing?
Exactly.
So, so a very undifferentiated, just sort of sack of these little cells. So if you can just imagine these sort of purple, pearls that sort of line the inside of a balloon. That's basically what the ovotestes looks like when the animal is a little better than halfway into its life.
We live in a culture obsessed with dieting, weight loss, and exercise. And that can make eating disorder behaviors easy to miss. But the reality is, eating disorders are serious mental illnesses that take a major toll on your health and your life. But recovery is possible. Eating disorders are more common than you might think. Chances are you know someone who is struggling with one. Or maybe you're struggling yourself. If you're concerned about an eating disorder in yourself or a loved one, I want to introduce you to Equip. Equip is a fully virtual, evidence-based eating disorder treatment program that helps patients achieve lasting recovery at home. Every Equip patient is matched with a multidisciplinary care team that includes a therapist, dietitian, medical provider, and mentors. And you get a personalized treatment plan that's tailored to your unique goals and challenges. Equip treats patients of all ages and all eating disorder diagnoses. It's covered by insurance, and there's no wait list. If you think that you or a loved one could be struggling with an eating disorder, don't wait to get help. Visit equip.health to learn more. That's equip.health.
Over 90 of the top 100 U.S. accounting firms trust Bill to simplify and secure bill pay. That's proven financial infrastructure built on over $1 trillion of secure payments. Visit Bill.com/proven for a special offer.
To tip off this NBA season on FanDuel, you can choose your own rewards, which means you can play your game any way you want.
I get to choose my rewards?
Yep.
Great! Now, excuse me while I lock in.
All customers choose your own reward right now in the FanDuel app. 21 plus and present in select states. 18 plus in Kentucky. Opt-in required. Rewards are non-withdrawable. Restrictions apply, including bonus and token expiration, leg requirement, and max wager amount. See full terms at FanDuel.com/sportsbook. Gambling problem? Call 1-800-GAMBLER.
And then what was interesting was the next month's batch of sea slugs all had this peculiar, I'm going to say pigmentation. Yeah, on parts of their ovotestes.
Okay.
Now, what I just described to you with the balloon and that sort of purple layer of cells from the stain is what I saw on the inside when I made thin sections of the animal. Because we were responsible for making all our own slides from scratch, right?
Right.
Which was that was the other part that I loved the most. So the two things I loved the most about my thesis were basically the things that were closest to doing studio work.
Right.
Yeah. So.
This was prior to you doing studio work.
Oh, yes. Yeah.
So the sea slug kind of introduced you to studio work and made you the artist you are today.
Kind of. I couldn't stop making slides. At one point, my thesis advisor was like, you have like 1,100 slides. You're fine. I'm like, but I just want to keep making them.
Right.
Because the whole process was so interesting. Because I'm going to sort of go on a bit of a tangent.
Please.
Well, the animal, like you and I, we would say they're hydrophilic, right? They're full of water.
Right.
Right? Water is sort of within their systems and their bodies. Well, when you create microscope slides of an animal for light microscopy, which is done less and less nowadays, And that's another thing. I tend to like obsolete technologies, or technologies on the cusp of being obsolete. And this was definitely on the cusp of being obsolete at the time.
Amazing.
Yeah, when you're preparing cells for light microscopy, you have to embed them in wax. And that's how you can make thin slivers of the animal without losing the shape or the form of the cells.
Oh.
And so you can't just take a watery animal and throw it in a chunk of molten wax.
Sure.
Because the cell membranes would rupture, and so you just have a mess.
Right.
Right. There'd be no animal to look at. It would just be a pile of weird goo.
Sort of like in the remake of The Fly, when the baboon goes into the chamber and it comes out on the other side.
I'm trying to remember. Like, I saw
David
one with,
Cronenberg. It was with.
I didn't see that. I saw the
it's a
old
classic.
one. But wait, the remake of The Fly, was that
Of
the one
The
with
Fly.
Jeff Goldblum?
That's the one.
Oh, yeah, I've seen that.
There you go.
Yeah.
Anyways, back to sea
It was a long
slugs. Sorry.
time ago.
Sure.
Yeah, so what you have to do is you have to take these watery animals and you put them through a series of baths, solutions.
Oh.
And the solutions go from being, very generally, they go from being all water based to through alcohol, and alcohol's the key. So you start with 100%, watery type stuff. And then the next bath you put it in for the next, 10 minutes or whatever, it'll be 70% water, 30% ethanol.
Oh.
And then the next one will be like 50-50. And then the next one will be like more ethanol than water. And so you kind of do it in these slow phases.
Right.
Because the alcohol, chemically is something that goes fine with water. It'll
Right.
combine with water just fine, but it will also kind of combine with something that's hydrophobic. So that was sort of the link. So you have you start with water or something that's, I actually don't remember what the first bath was, but it was something that was like water.
Sure.
And then you run it through a series of maybe 5 phases where the proportions of water to alcohol change, sort of like a spectrum or a continuum, I guess. Where at the end of it, you're at like 95% or 100% ethanol, which, by the way, if you ever dared drink it, would kill you immediately.
Well, I'm glad you didn't
And that was
drink
the
it.
first thing they warned us when they let us loose in the lab
Right.
in 4th year. It's like, don't drink the ethanol, you will die.
That's a great tip.
Yeah, it's a pro tip from my thesis advisor. And so after, it's 100% ethanol. So you can imagine you have this very thin, like just a couple of micrometers thick section of an animal embedded in wax. It goes from the alcohol to, there was another chemical in the step between the alcohol and the wax. And to be honest, I don't remember what that was. But there was, it was something that helped infiltrate the wax into the animal.
Oh, I see.
Without breaking the cell membranes.
Wow.
Right? Like, you have to be super careful. So there was infiltrating the wax so that it would get into the animal and basically almost plasticify it. And then once that's done, the whole thing would go into a hot molten cup of wax.
Wow.
A little cube.
Right.
Like an ice cube tray almost. Mm-hmm. And then after that hardened and dried, then you take out that block of wax, attach it to the end of a machine called a rotary microtome. Mm-hmm. And what the microtome does is, well, those machines they use when they're slicing salami or whatever, right?
Sure.
It's sort of like that.
Okay.
Only instead of sort of pushing the item you're slicing back and forth, side to side, it is held stationary, and the blade is actually what moves.
Oh, okay.
It moves up from the bottom and slices a thin rectangular section, just a few micrometers thick, upward in an upward motion. Mm-hmm. And so you can slice through the animal longitudinally from the left side of the animal to the right side, or you can slice through the animal cross-sectionally from the head to the tail. And it all depends on which way you orient it when you put it in the microtome. And so I would get these sections of animals where it'd be like, oh, here's the very tip of the left side. Oh, now we're going inside the animal a little bit. Oh, now we're at the halfway point. And so that was how I could locate the ovotestes.
Wow. That's fascinating.
Yeah, well, I certainly think it is. And it's kind of an interesting way to see something through space and time when you see it in sections.
Sure.
Anyhow, so I did this with my samples from all 3 times that I collected them.
Right.
The October, the November, and the February groups. And so I personally took them through this process of turning them into little wax cubes, basically, and then thinly slicing those wax cubes. And here's, if you can imagine, and because I know this is a podcast and I have to use my words to be visual, these sections, these cubes of wax were maybe about 1 centimeter by 1 centimeter by 1 centimeter.
Wow.
Very small.
Sure.
And then as you slice, you get these sort of centimeter by centimeter squares, right? Mm-hmm. Now the neat thing is the blade of the rotary microtome goes up, slices upward, and then comes down, and then goes in and slices upward. The thing that it just sliced, that square that it just sliced, actually stays on the tip of the microtome in such a way that the next slice you make kind of attaches itself to the past one. And do you know what it looks like after you do 5 or 6 slices? It looks like the most adorable strip of toilet paper.
Really?
But it's actually wax with little thin sections of animal on it. And then very carefully and without breathing on it, you pluck that strip with tweezers, because if you use your hands, it'll melt the wax.
Oh my goodness.
And you float it very gently on the surface of a warm water bath that's not moving at all.
Right.
And then you take a microscope slide that's been treated with gelatin, so it's got a sticky sort of surface on it, and you carefully slide it underneath the water, under where your floating bits that looks like toilet paper is floating, the piece of animal.
Sure.
And then you very carefully raise the slide up to the surface from underneath the sections you've created in such a way that the sections don't fall off the slide, but the water does. And then you have to let it dry. And then once you've let it dry, then you can run it through your series of stains. And the stains have to remove the surrounding wax to leave just the animal.
Wow.
And then infuse the color, which attaches to different biological materials within the animal.
And then you put it in the microscope.
Yes, and then you use a very cancer-causing goo to adhere the top of the microscope slide onto the main slide, like the cover, the glass slip cover. And so that's the final step in creating slides.
Well, there you go. Well, we'll have to find out more about sea slugs, because we just got to the sort of adolescent stage.
That's right.
And we've come to the end of this podcast. So
I assure you the conclusion is not so exciting that you won't be able to sleep.
Fair.
But I found some pretty neat stuff.
Well then, listeners, look out for episode 3 on sea slugs. Becka Barker, I want to thank you for bringing us episode 2. And when you're back in town, or when I'm in your town, we'll do episode 3.
I cannot wait.
Thank you. You've been listening to the Insomnia Project, as always. We are produced by Drumcast Productions, and this episode was recorded in Toronto, Canada.